Hi everyone, welcome back. Today we're solving construct the minimum bitwise array 2. So in this problem we are given an array nums consisting of n prime integers, and we need to construct an array of length n, and in the problem description it will be called ans, and in that array for each index I, the bitwise OR of the answer array of I and the answer array of index plus 1 will be equal to nums of index. So in other words, this with an OR operation with this will equal to nums of index. And we also need to minimize the value of answer of index in the resulting array. So if we look at this example, there's no operation for 2, so we will put -1 here, as it says right here. If it is not possible to find a value, then we will set to -1. For 3, the minimum number is 1. 1 OR operation with 2 will equal to 3. Right here is 4, because 4 or 5 will equal to 5, and right here is 3 because 3 or 4 will equal to 7. And in this example, it will be 9, 12, and 15 for 11, 13, and 31, and the reason for that is written right here. So this is what we return as the resulting array. So now that we have seen some examples, let's get to how we can solve this problem. So this is actually the same exact problem as construct the minimum bitwise arrays 1 or Leetcode 3314. The only difference is that the constraint in construct the minimum bitwise array 2 is more strict, so you will need to recognize this pattern to be able to solve it. So the pattern that we need to notice is that, so for these numbers, the number we put in the answer array would be these numbers. And if you notice a pattern is that we can get this number by having the original number subtract by the new number of zeros, with their 1 being 1 to the right of the first 0 that we can find in the original number, searching from the right. So as you can see, this subtract this will equal to this subtract this will equal to this, and this subtract by this will equal to this. And if you're wondering where the 1 come from here, well, there's technically a 0 here, so then we will place the 1 right here, right to the right of this, which would be in the 5th location from the right. So how we can solve this problem is we can iterate through all the numbers, and for each number, check its binary digit using the left shift method. So 2 to the 0 power is 1, 2 to the 1 is 10, 2 to the second power is 100, and so on and so forth. And more specifically, as we are checking the powers of 2, when we get to nums of I with an AND operation of the digit that we are at, if that is equal to 0, then that means we have a right at the first 0 starting from the right, which is what we are looking for earlier. Then we can set the number to nums of I minus the previous digit, which is what we are doing right here, and then we will add that number to the resulting array, and finally we can return the resulting array. So let's go through this example real quick. So the first one, the number 2, it does not have any number that satisfies the condition, so we add -1. Move on to the next one. When the digit is 1, it does not make it 0, so we go on to the next one. When the digit is 10 or number 2, it's not 0, so move on to the next one. And now when we set it to 4, then it is 0, so we will do 3 minus the previous digit, which is 2, is equal to 1, so we add 1 to result. Move to next number. For 5, when the digit is 2 to the 0 power, it's not 0, so move to next digit. Now, when we move 1 to here, it is 0, so we will do 5 subtract by the previous digit, which is 1, and that's 4. So we will add 4 to the resulting array. Now move on to the last one. When the digit is 1, it's not 0, so move on to next power, still not 0, next power, still not 0. Now when we set it to 8, it is 0, so we will do the previous digit, which is 4, and 7 minus 4 is equal to 3, so we will add 3 to the resulting array, and we can return this as our result. So the time complexity would be O of n log m, where n is the number of elements in the input array, because that's the number of elements we will iterate through, and m would be the largest number in the array, but we are iterating through its digits, so it would be log m instead of just m. And the space complexity would be O of 1, because this does not count as extra space since we are returning it, and the size of these variables will not depend on the input of the problem. So now let's get to the coding part. So we will first initialize the resulting array to an empty array, and now we'll look through nums. So for I in range length of nums, initialize number to -1, set the digit to 1, so that's 2 to the 0 power, and now we will check the condition while nums of I and digit does not equal to 0. Then we will calculate the number, which is nums of I minus digit. And then we will shift the digit. So digit, left arrow by 1, and then we'll append num to result. And after looping through none so we can return result, see if it works. Okay, perfect. Hope this is helpful. Thank you guys for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.